They are different environments, but at least we must describe about the type. This kind of type, the fixed, for example, if accepted, is going to be like this. The second one, the strip footing, is what we have in the beginning, and the capping beam is something that people might know that we have this solution. We're going to continue with the strip footing, and also the materials. This kind of control, because I'm not using this Spanish normative, they have all kind of solutions about the covering and the foundation covering as well, the maximum size of the aggregate. About the walls, the height of this wall is 350, and the wall level could be the backfill, the infill, and the without levels. So I'm going to continue with the infill. The infill here, they have different, well, I'll show you later what is the problem here, and accept that. And about the loads, it's possible to see what's going on with what's going to happen when we have an earthquake. These horizontal forces we can apply to the structure. We have the infill, the pass in the infill, in the lateral pressure is here. In the backfill, we have considering the passive thrust, and the one we are considering active thrust. About the option that we have several percentages of steel left over. And about the safety factors, clicking here in this yellow arrow, we have all these informations, okay? But if this is an example, but if you have all this data, you can introduce it here one by one, right? Same thing, this is for the walls, same for the foundation and the footing. About the reinforcement tables, remember, you can see what we have here by default. If you want to select one, select something, just make sure that you are doing the right things, okay? Because if you are not sure, try to make some changes and make this look for the results. Same thing about how we're going to see details about this software, this model. The general data, we have the ground level elevations, which is this one, the green one, 0. And if you have a rock, if you know that the rock is coming, after digging maybe 6 meters, so make sure that it's like that, because it's really important to know that when we are going to check for the slip coefficient over here, for sure, if we are very close, maybe gonna help, maybe not, but for sure, this is really coming from the soil solution from the lab. About the I'm gonna continue. About the soils, it's possible to modify this. You can modify also the color. You can modify the way to present it. And also you can add, if you have another soil on the bottom, whatever, you make sure that it's possible to change the color and the solutions. About the wall, you can describe one by one, right? And you can describe on the bottom. On the bottom, it's possible to take the chart key, which is by default is like that. Look, it's just continue the wall. If it's not the case, you can use it generic one and make it minus 30 centimeters means this in this side. But you want to do it, for example, in the positive directions, give you something like that. Okay. Once Once you have the solutions, you can check the reinforcement here, check all the parameters. Perhaps everything is going to be unacceptable depending. Okay. So going back to I don't want to have this. About the load increments, we can right now we have 0.25 tons by meter. It's over here, but we can introduce a horizontal force even any moment on top. Uh, we are taking some part of the loads on the side. Perhaps you have another building here. On the bottom, we can. Well, I'm gonna show you on the bottom what we have. This is the value of the soil. On top, this is the value of the soil, and well, now we can start doing the analysis. Okay, this is some check. I'm sorry, I haven't done the analysis. I'm going to do it. Same thing, we can display that kind of documents, and we can export that to the same files, PDF, doc format, text format, HTML format, and let's see. Okay, something and very really good to have is the face results. The face results give you, for example, the first one. What you are seeing here is the actual, then the shear. Shear is happening here when we change the soil, the bending moment, the air pressure, the hydraulic pressure is zero. When it's straight here, it's because zero, we are not taking that. And another analysis, the force diagram only that. But on the bottom, you have the shears, the bending moment, different presentation about the one before. Okay. And about the nice solution about the critical slip circle. This is very critical. Okay. We have to make sure about the safety factor, if it's verified or not. In this case, not verified, but at least we can see what is the problem. Let's see if we have problems. Well, at least we don't have any problems, okay? So same thing for about the reinforcement. We go back here for the reinforcement. We can modify, just clicking in one of them, you can modify once you modify this, if you do the analysis, you are going to go back to the same thing, this value. But if you modify this value, you increase this value, now you are over sure that you are not going to have problems. Same thing for about the 3D view. That's the 3D view. All right.